Hi everyone, my name is Dan Conroy-Beam. I'm a professor here at UCSB in the Psychological and Brain Sciences Department, and I want to talk to you today about some work I do on modeling human mate choice. So I want to start today with a really important question. I think now more than ever, it's important for us as researchers to ask, out of all of the possible research topics in the world, why is it that I should spend my time and your money on something like human mate choice? I think when it comes to mate choice, there's actually lots of good answers, but to understand one particularly good answer, it can be helpful to think about human mate choice from the perspective of deep evolutionary time. So we humans are, at the end of the day, biological organisms, and so that means our bodies and our minds are the products of biological evolution. And evolution itself is nothing more than the differential reproduction of genes, right? Genes interact with their environments to produce organisms. These organisms use their psychologies to select mates with whom they sometimes reproduce. And when these organisms reproduce, they make copies of the genes that help construct them. So this means that genes that make organisms who are good at reproducing will tend to persist and become more numerous over time, whereas genes that don't do that won't. And so these facts, this proximity of mate choice to reproduction and the centrality of reproduction to evolution, is why mate choice tends to both be subject to some of the most powerful selection pressures that sexually reproducing organisms experience, as well as tend to generate some important selection pressures as well. And this is why every biologist knows if you want to understand what an organism is like, and especially if you want to understand how it behaves, a good step can be to first try to understand how it mates. One of my favorite examples of this comes from these little guys right here. This is a male satin bowerbird. I know this is not the most impressive looking bird in the world, but I'm a psychologist at the end of the day, so what excites me about these guys is how they behave. And in particular, males of these species are pretty obsessed with building these odd little structures here called bowers. These are arrangements of twigs and feathers and flowers and literal garbage, but they're not haphazard arrangements. They have a pretty stereotyped structure. They can be pretty elaborate. In fact, I think this guy looks like he just won the Game of Thrones. Males have pretty stable preferences for how they build these things. So, for example, this species has a fondness for the color blue, so they've been known to incorporate things like blue flowers, bottle caps, and straws into their bowers. They're also competitive in bower building, so one male, if given the chance, will attempt to destroy the bower of other males and steal materials to bring home to his own bower. This means they also have to defend their bowers. They have to be vigilant against attacks from other males. So at the end of the day, it's a lot of these birds' precious time and energy that is spent constructing these odd little garbage towers. So why do male bowerbirds do this? Well, of course, it's because females like bowers. Or more accurately, females like males who build good bowers. So because females preferentially mate with males who build good bowers, over evolutionary time, male bowerbirds have become obsessed with bower building. Now, I think it can be a little too easy for us to look at this and say, oh, silly little birds doing such odd behavior just to mate. But I think bowerbirds could correctly look at us and point out that we humans have also been known to build elaborate structures in the name of love. Mating and mate choice is what we have painted and sculpted since antiquity. It's what we write, listen to, and sing songs about every single day. It's what we film and watch TV shows and movies and plays about every single year. Throughout human history, mating and mate choice have been responsible for some of our greatest acts of selflessness, as well as some of our greatest acts of destruction. And in the modern environment, we've created the largest and fastest and most powerful communication network in the history of this planet, and we use it in large part to find ourselves more mating opportunities in one way or another. So I think bowerbirds could look at us and correctly point out that we are just as obsessed with mating as they are. Now, all of that, I think, makes sense from the perspective of deep time. I think this also makes sense on more personal timescales, though. There's no corner of your everyday life that is unaffected by who you choose as a romantic partner, where you live and work, whom you consider friends and family, with whom you have children and raise families of your own. And so, accordingly, mate choice and the quality of our subsequent relationships is pretty robustly linked to a variety of aspects of well-being, including our physical health, our mental health, and our long-term financial success. And so, given all of these things, I hope you agree with me. If we want to understand what we are like as a species, and if we want to understand how to improve human well-being, then understanding how we choose our mates is probably going to be pretty important. That said, as true as that is, I can also let you know from personal experience, it's also unfortunately kind of difficult. Studying human mate choice, it's kind of an odd task. For one, human mate choice is particularly complicated for reasons we'll see in just a moment. But two, it's one thing to be a human studying mating in birds, but it's a different thing to be a human studying mating in humans, right? We all have lifetimes of personal experience and cultural messages that make it hard to think objectively, clearly, and scientifically about the nature of human mating. And that's why in my lab, we take a slightly different approach than a lot of human mating researchers. We're never so much asking the question, how do humans pick their partners? Instead, we ask a slightly different, but we think related question, and that is, well, if we had to, how could we build a robot that is capable of falling in love in the way that humans do? Now, I know that's a somewhat unromantic way of thinking about love, but we think it's helpful because answering this question forces you to answer two kind of sub-questions. One of those is, well, what are the challenges that this robot is going to encounter on its path to love, and therefore, what are the challenges that we as humans encounter when it comes to mate choice? And the second is, well, what kinds of information processing systems do we need to build into this robot's computer brain in order to overcome those challenges? And therefore, what kinds of information processing systems can we expect to find in our own minds? So how do we answer these questions? Well, especially lately, my lab has been working on developing a new technique, which we call couple simulation. The idea here is we go out into the real world and find people who have made actual mate choices. So for example, myself and my wife. We measure things about these people that we think are relevant to their mate choices. So for example, we might measure each of our preferences, what we want in a partner, and each of our corresponding traits, what do we actually like. And then once we have that information, what we can do is essentially avatar these people. That is, we can create little simulated robot copies of each of these people that inherits all of their preferences and traits. So we can do this for a whole bunch of people. The first thing we can do is we can see, well, who is actually pairing with who, right? What are the mate choices that we're actually trying to explain here? And then, because these little simulated robots live inside our computers and we control everything about their lives, the next thing we can do is we can force them all to break up, and we can throw them back into a simulated mating market and force them to choose mates again. And then lastly, what we can do is we can see how accurate was the simulated mating market in reproducing these robots' original mate choices. So for example, this market here correctly paired A with A, but it mixed up B and C. So we would say this market has a 33% accuracy. So why do we do this? Well, the intuition here is, if we happen to know everything that was really important about actual human mate choice, and we were able to correctly simulate it in this simulated mating market, then these robots should tend to make the same choices that their real-world counterparts did. Or another way of saying that, conversely, if these robots are making different mate choices than their real-world counterparts, then that means we have something wrong in our simulated mating market. So that means the more and more accurate we can make these simulated mating markets, the more and more confident we are that we're accurately reconstructing the real facts about human mating. Now, in order to do this, though, we have to be able to program all of these little simulated robots to be able to overcome the real challenges that people face in actual mate choice. So what are those challenges? Well, there's lots of them. I'll talk about three particularly important ones today. And I'll start with this issue of figuring out what matters in a potential mate to begin with. So when we set up these simulations, we have these little simulated robots. We're going to throw them into a mating market where they have lots of potential mates. And the first thing this robot is going to notice about these potential mates is that they differ from one another in all different kinds of ways, right? So some of them are going to be taller than others might be a little shorter. Some of them are going to be kinder, maybe others are a little bit crueler. Some of them might have particularly wrinkly elbows, whereas others will have relatively smooth elbows. Maybe some possess large amounts of money, whereas others have pretty large stamp collections. If you think about it for a moment, I think you'll see there's literally no end to the number of different ways that different people differ from one another. Now, we as humans know that some of these dimensions of difference matter more than others, right? It probably matters more if your partner is kind than if they have a wrinkly elbow. But we have to have some way of giving that knowledge to these simulated robots. That is, we have to have some way of giving these robots what we'll call preferences. And by preferences, what I mean are psychological parameters that dictate what dimensions are relevant to evaluate in a potential partner, and then within those dimensions, what values are actually favorable. That is, the robot needs to know that kindness matters more than elbow smoothness, and that within kindness, kind partners are better than cruel partners. Now, it turns out, documenting the nature of human mate preferences is one of the biggest areas of research in human mating research. There are decades and decades of papers just charting what it is people prefer in potential mates. One really common research methodology in this literature is one that I use quite a bit in my own lab, is we just ask people. So we give you a standardized, validated questionnaire that might ask you a question something like this. How generous should your ideal romantic partner be on a 11-point scale, where 0 means extremely selfish, 10 means extremely generous, and 5 is the average person? So I could ask you this question about a lot of different trait dimensions. I could also ask you multiple questions about each dimension. So what is your ideal value, but also what's the minimum value you would accept? What's the maximum value you would accept? And also, how important is generosity compared to other things, such as, height or elbow smoothness? So if I asked you a bunch of questions like this, you might give me data that looks something like this. So this is data from a recent study in my lab. We asked about 1,000 people for their mate preferences on 16 different dimensions. You can see these dimensions going down the screen. For each dimension, they reported the minimum value that they would accept, shown in a blue triangle, the maximum value they would accept in a partner, shown in a blue square, their ideal value in a partner, their perfect partner would look like this, that's an orange circle, and they also ranked and rated how important each dimension was compared to all of the others. And so the dimensions are ordered in terms of their relative importance. The ones that people said are more important are towards the top, and the ones that people said are less important are towards the bottom. So if you scan this for a moment, you'll see a lot of pretty typical findings for this literature. So for one, if you look towards the top of what both men and women want, both men and women agree on 3 dimensions that tend to be pretty important when it comes to considering a mate. These are kindness, intelligence, and good health. Both men and women say that these are among the most important things to them when considering someone as a potential romantic partner. If you look towards the bottom, I think sort of in contrast, interestingly, to some sort of cultural stereotypes, you see both men and women agree that among the least important dimensions are social status and artistic ability. So if you're looking for a partner, maybe don't bother learning the guitar, maybe just read some more books or be a little bit more friendly. You also, even though men and women do agree on a lot of things, you also see there are some pretty typical differences as well. So men, on average, tend to rate physical attractiveness as being more important to them in a potential partner than do women, and you can see that's true in our data as well. And women, on average, tend to rate good financial prospects as being more important than do men, and you see that's true in our data as well. Now, this is just one sample of Americans, but it turns out this is a pretty robust and pretty cross-culturally universal phenomenon. So here's data from a recent paper published by my graduate student, Katie Walter. Here she analyzed data from a large sample of about 14,500 people from 45 different countries around the world. In this graph, all of the shaded in countries are countries from where we had data. And all the participants in the sample filled out a standardized mate preference questionnaire, not unlike the one I just showed you. They reported their preferences in an ideal romantic partner on 5 different dimensions. That was kindness, intelligence, health, physical attractiveness, and good financial prospects. And what I'm showing you here is the average sex difference in these preferences across all these different countries. So going across the bottom is the size of the sex difference, going down are the different dimensions, and then each dot here represents one of those 45 countries. So you can see across the world, men and women were in general agreement when it comes to kindness, intelligence, and health. Around the world, both men and women agreed that what they want the most in a potential romantic partner is good health, high intelligence, and good kindness. But around the world, with the exception of just 2 countries, men were on average saying that they wanted more physical attractiveness in a partner than were women, whereas in contrast, in all 45 countries, with no exceptions, women were saying around the world that they want more financial prospects in a potential partner than were men. So, I think, from these findings from this literature, we have a pretty decent sense of how we can build in realistic human mate preferences into our robot. So that's good, but that's just step 1. In fact, the existence of these multiple preferences creates a new challenge of its own, and that is, well, figuring out who is a good mate to begin with. So to understand this challenge here, let's imagine for just a moment that our robot has just 3 preferences. So let's say for intelligence, kindness, and physical attractiveness. The question here is, well, what is this robot supposed to do when it encounters, let's say, one mate who is maybe kind, attractive, but a little bit naive, much like early Game of Thrones Daenerys, but it has to compare that mate to someone who is, let's say, intelligent, attractive, but evil, much like late Game of Thrones Daenerys. The question here is, how is this robot supposed to compare these 2 potential mates, each of whom fulfills some of its preferences, but doesn't fulfill other preferences? Now, in order to make these kinds of comparisons, what our robot needs is some kind of psychology that's able to take information from each of these individual dimensions and boil it down into some sort of overall summary. We call this process mate preference integration, and we call this overall summary mate value. And this process is what allows us to say, some mates are just higher in value to me than are others. Now, there are a variety of algorithms that this preference integration psychology could use to compute this overall summary. I'll talk about just one today that has worked pretty well in some of our prior research. This is called a Euclidean integration algorithm. The way this works, we can take these 3 preferences that I've been using as an example, and with them we can define a 3-dimensional space, where one direction through the space represents increasing intelligence, another represents increasing kindness, and then kind of coming out at the screen at you is increasing physical attractiveness. So with these 3 dimensions, we can form a sort of 3-dimensional preference cube, where each point in this cube represents a possible set of preferences. So we could go out into the world, and we could find a person and ask what their preferences are and find where they belong in this cube. So for example, here is a person who ideally desires a partner who is very intelligent, very kind, and moderately physically attractive, a pretty reasonable set of preferences. We could also find this person a mate and see how intelligent, kind, and attractive they really are. So here's the mate who is not very kind, not very intelligent, but extremely physically attractive. So we can see intuitively, right, this mate is not a very good match to this set of preferences. What a Euclidean integration algorithm does is it captures this mathematically by computing the straight line distance between those 2 points. And mate value becomes proportional to the inverse of that distance. So a long distance means low mate value, a short distance means high mate value. So why do we think this is a good model of what's actually happening in our mind when we're evaluating our potential mates? Well, we have several pieces of evidence. I'll talk about just one relatively simple study today, just for the sake of time. So these are results from a paper I did in 2017 with David Buss. Here what we did is we showed, I think this is about a sample of about 300 people. We showed these people a series of profiles of hypothetical potential mates. And each of these profiles just said, here's a hypothetical mate. They are X kind, Y intelligent, and Z attractive, and a bunch of other things. How attracted would you be to this person as a potential long-term romantic partner? What the participants didn't know is we had experimentally manipulated these profiles so that they were either shorter or longer Euclidean distances from the participants' preferences. So this graph is going to show you the results. Going up the y-axis is the long-term attractiveness ratings given to these profiles by the participants. And then going across the bottom is going to be those Euclidean distances. So on the left are going to be profiles that were far away from the participants' preferences, and on the right are going to be profiles that were close to the participants' preferences. So if people were actually using this Euclidean integration algorithm to compute how attracted they were to their potential mates, what we should expect to see is a pattern of results that's something like this. That is, potential mates that are a shorter Euclidean distance from your preferences tend to be found more attractive. And that is exactly what we see here. So we think this is pretty nice evidence that this Euclidean integration algorithm is at least a decent model of how people are integrating their preferences to form overall evaluations of their potential partners. So that allows us to give our robots not only preferences, but also, we think, a pretty decent model of integrating those preferences into mate value estimates. So that's good. We're making some progress. But now our robot is going to confront a third challenge, and this is the most difficult challenge of all. This is actually navigating the mating market. So here, we're going to throw this robot into a mating market where it has lots of potential mates, which is good, but also now lots of rivals, which is less good. And this mating market is going to impose a number of constraints on how this robot can behave and who it can choose as a partner. One of these constraints we've already kind of talked about. This is this issue of availability, right? There's no guarantee that your perfect partner is going to exist in your local mating market, so you're going to have to make some trade-offs, some compromises in terms of your preferences. There's also now an issue of competition, right? Nobody's ever the only person looking for a partner at any given time. So you not only have to find a good mate, but you have to find them before your rivals do. And then last but not least, the most difficult constraint of all is that human mate choice is mutual, right? It's not enough to choose a mate, they also have to choose you back. And there's no guarantee that the people that we prefer will also prefer us. So in order to deal with these constraints, in order to successfully navigate these mating markets, what our robots need are what we'll call mate choice algorithms. And by this, I mean sets of decision rules that dictate who the robot pursues, but also what the robot does if that mate doesn't pursue them back. Now again, there's a variety of algorithms the robot could use. Much of our work is comparing different algorithms, but I'll talk about just one algorithm today that again has performed pretty well in our research so far. To oversimplify things just a little bit, this algorithm is essentially a reciprocity model. So the way that it works is initially all the robots in the mating market just compute how attracted they are using that Euclidean integration algorithm I showed you just a minute ago. And then afterwards, each robot just gradually adjusts its feelings of attraction to all of its potential mates according to how much those potential mates liked them back in the past. So if they got a stronger signal of mutual interest before, they increased their attraction to that partner. But if a partner wasn't so interested in them before, they decreased their attraction to that partner. So you can see how this works by looking at this little social network graph on the left. So each circle in this graph represents one simulated robot. This is a sample of about 100 simulated robots. These were based on 100 real-world people who were members of 50 real-world romantic relationships. The blue lines connecting the circles represents the degree of attraction between the robots. So a thicker line means the robots are more mutually attracted to one another. A thinner line means less mutual attraction. The robots also try to stand as close as possible as they can to the people that they're attracted to. So you see, initially, the robots are just computing their attraction based on this Euclidean integration algorithm. So at the start of the model, every robot is a little bit attracted to every other robot. But if we start the model running, reciprocity starts to take over, and you'll see some of these lines gradually start to get thicker and bolder, and then some of the other lines start to get thinner and gradually disappear. And eventually, each robot is going to move around the screen to try to stand closest to the robot that they're most attracted to. So the end result is something like this. So even though every robot initially started out being a little bit attracted to everyone, by the end of this reciprocity model, each robot has chosen one partner, or sometimes two partners, with whom they have a strong mutual bond. So now we can ask, well, how good is this algorithm at reproducing real-world mate choices? Well, in this particular sample, this model achieves about a 76% simulation accuracy. That is, 76% of the real-world couples that were used to generate these robots are reproduced at the end of this reciprocity algorithm's run. Now, that sounds pretty impressive. Hopefully there is an asterisk here. It turns out this is easier to do when you use a smaller sample than when you use a larger sample. If we use this full sample of about 1,000 people, then we see accuracy drops to about 40%, which I think is still pretty good, but also tells us we still have some work to do. Now, this shows us that maybe we have an algorithm that can reproduce mate choices, but I promised you robots that could fall in love. Are we making any progress on that dimension? Well, one way we can see that is we can ask, well, 40% accuracy, that's pretty good, but what's going on with the 60% of couples that we're getting wrong? Well, fortunately, we also asked all of these people to reflect on a number of dimensions of relationship quality using a variety of standardized relationship quality measures. And so we can ask, are there any differences in relationship quality between the couples that this algorithm is accurately reconstructing versus the couples that are inaccurately reconstructed by this algorithm? So here are these results. Going up, the y-axis is going to be relationship quality. Going across the x-axis are a variety of standardized measures of relationship quality. The pink lines you're about to see in a moment, these are going to be the couples that were inaccurately reproduced by our algorithm, and the blue lines are going to be the couples that were accurately reproduced. And so we can ask, do the accurately reproduced couples have any difference in their relationship quality compared to the inaccurately reproduced couples? And the answer is yes. Those couples that are accurately reproduced by this reciprocity model, they have higher levels of satisfaction with their relationship according to two different standardized measures. They are more committed to their relationship according to two different measures. They have more investment in the long-term well-being of their relationship, and they report stronger feelings of romantic love. These are all the kinds of positive aspects of relationship quality, but you can also look at more negative aspects of relationship quality. So the accurately reproduced couples experience lower levels of romantic and sexual jealousy. They experience lower levels of attachment avoidance, which is essentially difficulty feeling close to your partner. And they also experience lower levels of attachment anxiety, which is essentially, concern that your partner is going to leave you. So overall, it seems the couples whose mate choice is more in line with this reciprocity algorithm just have higher quality relationships across all sorts of dimensions that we can measure. So that gives us a little bit of confidence. Not only do we have an algorithm that can reproduce real-world mate choices, but we're making a little bit more progress towards building robots that can actually fall in love the way that humans do. Now, this is all pretty exciting. We're pretty happy with these preliminary results, but they are still preliminary. There's lots of directions we want to go in the future. So for one, you might be able to tell from my language, most of our research so far is focused on heterosexual cisgender mating, but we also want to have more inclusive theories of human mating. And so we are actually presently doing some work to also further explore LGBTQ mating. We also, we do a little bit of cross-cultural research in my lab, but we are still heavily biased towards American samples and towards quote-unquote weird societies, that is, Western, educated, industrialized, rich, and democratic. But we're also very interested in expanding the cross-cultural scale of our work so that we can explain, the variety of mate choice that happens all around the world. And of course, we want to just keep building better models, right? Better models of the processes I talked about today, but models of other things that I didn't have time for. Things like mate perception, that is, how do you know who is kind and who is intelligent, especially given that potential mates have incentives to deceive us? Who do we even consider as a potential mate to begin with, right? Are some people just disqualified off the bat before we even get to our preferences? And also, we do want to push beyond mate choice and look at relationship regulation. That is, what really are the specific calculations that are underlying our feelings of, for example, romantic love. But with that, I'll stop here. I'd like to thank a number of people, my students, especially Katie Walter, Ben Gelbart, Isaiah Geze, and Jared Klashevsky. I'd like to thank the National Science Foundation for funding this research, and I'd also like to thank you for your attention.